Hey folks, so in the previous video we had solved this problem using standard calculus, using just finding a couple of integrals and doing a little bit of algebra. So in this one, what I'd like to do is demonstrate how to do it without any calculus at all, using technology, quote unquote. I'm going to use Google Sheets because I'm a fan of that product, and you could use Excel. It'd be very similar, almost identical. But again, it's a car. So the word problem is it's a car traveling at 40 feet per second. It decelerates, and yes, I misspelled decelerate, at a constant 5 feet per second squared. How many feet does a car travel before coming to a complete stop? So that's the statement of the problem. And let's see. So this will be interesting because we can compare how long it takes either way. So you have to have a little bit of facility with Google with spreadsheets. It's really just a couple of formulas. So to get to Google Sheets, I go into my Google. So I signed into Google here, and if you click on this little rectangle, it says Google Apps. You go down until you find Sheets, and we're just going to create a new one, blank spreadsheet, and what we're going to do is we're just going to look. We're going to have a row for basically every second that goes by. We're going to have three fields. One is time, and three columns or three fields. And the second one will be velocity, and the third one will be distance. And now what we're going to do, we start out at 0. Now, how do we get the rest of the time? We could just key them in, but we don't know in advance how far we want to go. So we're going to use a formula. And to use a formula, just like with Excel, you start with an equal. And you use the cell that you want to reference. And in here, it's column followed by row. And the columns are letters and the rows are numbers. So here, this is cell A4. So I want to look at cell A4, and you can see up here, it's appearing. So A4. And I want to add 1 to it because that's the next one I want to get. So each one is going to be 1 plus the one before it. That's going to be 1, 0 plus 1. And now what I do a copy, and then I just kind of drag on the rest of the cells. Let's go down to 20. And you see how they're highlighted. Click on paste. So there's the rest of them. I'm going down to, 16. That's good enough. And now what's the velocity? Well, when we start, the problem tells us it's 40 feet per second. We know we're going to go down by 5 at each step. So we don't really, so what is this going to be? It's going to be 40 minus 5. So we're going to use another formula. So it's going to be equal to, and that should be B4. Does it do it? Yeah. Minus 5. There's 35. Rather than keying them all in, I'm going to, again, do copy and paste. And what it's doing is it's updating that reference. So you can see in A5, it's looking at, in B5, it's looking at B4. In B6, it's looking at B5. So it updates the formula as you go along. That's known as relative cell referencing. So it knows when you copy that you want to just keep going to the previous one, the previous cell. And now the distance traveled, well, at first it's 0. And then how do we get, and this is where it gets a bit tricky, and this is probably the trickiest part of it, is how far have we traveled when we went from 40 to 35? Well, it's going to be whatever we traveled before, because it's cumulative. So it's going to be, it'll be C4. I'm going to put right here equals C4. And we're going to add something. And what are we going to add? Well, the distance covered should be the velocity times time. But between 0 and 1, what was our velocity? It wasn't Was it 40? Was it 35? No, because it's constant acceleration, the distance is halfway between 40 and 35. So it's halfway between those two times the time, which is 1 second. So we really traveled, it's the average. So it's 1 second times, well, what's the average of 40 and 35? Well, it's going to be, and I'm going to use the cell references for that. So it's B4 plus B5 parentheses. You can see it appears up here in this bar divided by 2. I hit enter. And that's 37.5. That's midway between 35 and 40. So that's how far we've traveled. And now this is the part where the formula, we could key all these in, but if you go and you can see what the formula is doing, it's accessing C4, B4, B5. It's going to update that. If I do a copy and I once again drag down, do a paste. In Excel, I think you might have to choose paste special and do formulas. But here, it looks like all you have to do is do a paste. And now, I should have mentioned this earlier. I really don't care about the entries where the velocity is negative, because you're not going to deaccelerate so much that you're going backwards, right? So that's a case where, the real world, this doesn't fit in with the real world. So we're going to get rid of anything where the velocity is negative. And we just stop when the velocity is 0. And we can see here, that's what we wanted to know. And this row gives us the answer to our word problem, because when the velocity is 0, it's at t equals 8 seconds. And we traveled 160 miles. So I can even put that in bold. There we go. There's our answer. And did that take as much time as the last one? I don't know. But we'll see when I look at the end of the video. But yeah, that's 160. And that's another way to do it. And it's just using these. And you can see, if you look at the first formula, you can see C4, B4, B5, and now you advance, go one row more. Now it's looking at C5, B5, B6. So it's always looking at the previous distance plus the average of the velocities between the time that was elapsed. So you can see that the rows that's using that relative cell referencing, which is one of the most valuable things with spreadsheet formulas. So that's it for now, and perhaps we can come up with another way to do this. We'll do it. And again, if you want to use Excel, if you have Excel on your machine, that's just as easy. So thanks, and guess we'll see you next time.